Hello, welcome back. So in this lecture, we're going to continue our discussion in chapter 6. And the previous sections, what we discussed is about package private and the inheritance. Um, so for the inheritance, yeah, it does provide quite good benefits, but in some circumstance, if we are not careful and subclass don't override the superclass's method, it may expose security hole. Okay, so that's what we discussed for the last session. And in this session, we are going to discuss uh, final method and final class. Okay. And the final keyword, if you recall, previously we already use it for variables. And when we use it for variable, then that variable cannot be changed. So it's kind of like a constant variable, but it's not always true. Okay. Uh, Regarding the contents sometimes. So it's in Java based on the data. If the data is a primitive type, if the data is primitive type, then the actual value cannot be changed. But if the type is a reference type, so object, okay, then that means the reference arrow cannot be changed, but the attributes of the object can still be changed, okay? So, if you recall, is it like array, okay? So you can define some array like a final, is it int ARR, okay, and then equals, suppose like 10, 20, 30, something, is it? So the idea is that ARR on stack. So here is a heap, and heap you have that 10, 20, 30, is it? So it's a point to this block. So this arrow cannot be modified, cannot be changed. Okay, but the contents you can change, like to -10, -20, -30. Okay, so that's regarding the reference type. It's this arrow you cannot let it point to another new block. Okay, that will not be allowed. And so besides final can be applied to variable, you can also apply to method. If you apply it to method with the final keyword, that means the method cannot be overridden. Okay, so cannot. And we can also apply it to class. If the class is defined as final, that means it's a final class. It cannot be extended. So it cannot have subclass. Okay, so that's the difference when it is used for variable, method, and class. Okay, then let's compare the concept of immutability and the keyword final. Okay, so immutability is applied to object. Okay, but the final keyword, if you recall, we can apply it to class, method, and variables. And the definition for immutability is the object state cannot be changed. Okay, so so the immutability, if you recall, string class is immutable. Okay, and string class is immutable. So if we do string s equals hello. Okay, so then what this means, so this hello will be allocated a block of memory on heap. Okay, so, and this as on stack. So it's going to point to this memory block. So immutability, so this string class, you cannot change. That means you cannot change the hello. So once it's you cannot change, but you can. So suppose AB, is it? But you can reset S to a new memory block. That's allowed. So this is regarding immutability. So it's the memory block. Once you filled with some contents, then the contents you cannot change. You cannot change them. Okay. And for the final, then for variable, that means you cannot change value. But in Java, value is has two different categories. For primitive, it's basically then just constants. But for reference type, it's their reference cannot be changed. Okay. And for method, it's cannot be overridden. For class, it cannot be extended. So that's the difference between these two definition. Okay, it has some connection because for object, if you don't want object state to be changed, then we need to basically define the class as a final class. Okay. Okay, and so here let us have a break, okay, from the chapter contents. So this is a national park that I went to, so I took a picture of it, and yeah, it's pretty cool. And here is another picture also from that national park, and uh, just be careful, okay? All these stumps, you can see it has the circles, is it? So this is basically tree stump, but it also looks like rocks, is it? So yeah, so can you guess which national park is it? And the answer is it is Petrified Forest National Park, and it's in Arizona. It's a very nice national park. Okay, so that's about the context, concepts. And next, let's take a look a example, okay, to have a better understanding uh, of the final keyword applied to method and class. Okay, and so this example is uh, in the chapter, it's Java Inheritance Example 4 final, okay? And it has two package and two related Java file database member and attacker database member. They belong to this my data package. And the driver, we put it in the my data client package, okay? So here we have this package defined, and then the first class is database member class, and it implements, this is an interface. So don't worry, okay, later on we are going to learn. So let's take a look. This is the instance variable. And it, oh, not instance, this is class variable, okay. And it also has a keyword final, so that means it's constant, its value cannot be changed. And then we have this array. So this is array and it's final, is it? And here is the memory block that is allocated on heap. Okay, so because it's final, so that reference on the heap memory cannot be changed, but the contents in this array can still be changed. Okay, so be careful here. Okay, value in the array can be changed, but the block, this block, point to this block cannot be changed, but the contents you can change. So that's what this final for reference mean. Okay, and here this just a regular instance variable shared. And then next, let's take a look. So we have a default constructor, so it's just initialize the array with specified value, okay? And we also have a explicit value constructor, and its parameter is another array, okay? And what it does is it first call this, so this will call the default constructor, okay? Then it will check if the instance variable, the data, if it's got memory, okay? So if it's not allowed now, and if it has more than, so it has at least one element, is it? Then what you are going to do is we are going to find the cap, okay? So the smaller one between the existing, between this parameter one and that n, okay? Find the minimum one, and then we are going to do the assignment to assign this data to, so be careful, okay? This is parameter. This is parameter, okay? And this is the instance variable. And also remember it's defined as final. Final means that memory block cannot be changed. So this is our constructor to constructor. And then we have the toString inherited from object class, but we defined a final. So that means any subclass, they cannot override it anymore, okay? And we also define this toggle shared method is also final. So the subclass cannot override it, okay? So it will toggle that shared variable. So that serves as a flag. And then we also have this update contents method. It's also defines final, so no override anymore for subclass, okay? It's based on that shared, okay? So if shared is false, okay, it's not, then you are allowed to negate the data, okay? So this is just the contents negated. And we also have this get data method. It returns an array, okay? What it returns is the array's clone. And be careful here. This data, because data is array, okay? So for arrays, Java arrays clone method, it's a deep copy, okay? So basically on heap, if you already have this, so this is for data, is it? And then you're going to have another copy, okay? Copy. And this will be the return, return a clone, okay? Okay, that's this database member class. Then let's take a look. The second class. So we define a class that's also in this my.package, and it's attacker database member, okay, and it's a subclass of the database member class. It also implement that clonable. And its default constructor just call. So for this class itself, it doesn't have any instance variable, okay. So it call the superclass's constructor, and same thing here, it just call the superclass's constructor. And here it has its clone method. It returns the superclass uh, instance. Okay, so what it does is it create the attacker. Okay, initialize its null, and then what it does is call the database members is a clone method. But if you recall, in database member, it doesn't override the root class objects clone method. Okay, so basically this is super clone, so this is from objects because database mem doesn't have its own version. So what this clone does is return a shallow copy. Okay, shallow copy, so basically it's aliens of the data. Okay, that array, if you recall, okay. And don't worry about this try-catch exception, okay, we will discuss in later sections, in later chapters, okay. And then next, let's take a look. Okay, and we also have this function called get deep copy. Okay, and it return this class uh, uh, type, so attacker database member. So what it does, it is it called new, is it? And with this new, it's using what? Using the deep copy of data. Okay, and it's also new, is it? So this is a real deep copy. Deep copy, okay. Next, let's take a look at the driver part. Okay, so in this test, the driver it belongs to package the my.client, okay. And what it does is first create the attacker uh, object, okay. And then, so this attacker clone, okay, attacker clone, the type is data member, a database member. It's called attacker's clone method. Attacker, let's take a look. If attacker has a clone method. Okay, yeah, the attacker's clone method, if you recall, it's a shallow copy. So basically this is a shallow copy of attacker, okay. And this attacker copy, the type is database, and it's attacker get a deep copy. So that's a deep copy, if you recall, okay. So the attacker clone, type is static type is database member, and but its dynamic type is attacker database member. So same thing for this attacker copy. Okay. And then, so after we create all these three, we just try to output that, okay, the two string. And we can see the outputs here. So before updating, you see the outputs. Yeah, so everything is good with the original one. And then next, let's take a look. Okay, and the attacker clone, okay, then you do something. Attacker clone, you said, okay, I'm going to toggle the shared. So shared, then it's changed from false to true. Initially it's false, is it? And then you try to do the update contents. Update contents only if uh, shared is false, is it? Then you can do. So you won't be able to do something. So nothing done. And then nothing done. And then we can output. Is it attacker and attacker clone? So basically these two are the same, point to the same reference. Yeah, so nothing will change. Attacker copy, nothing done on it. So of course, nothing will change. Okay, and so when attacker clone do the toggle, is it? So the idea here is, so we have this heap. Heap has an array 150, 160, 170, is it? Yeah. And you have attacker point to here. You also have that attacker clone also point to this same array, okay? But the attacker also has that shared. Okay, the shared, so that's attacker's shared. And shared is a Boolean value, so it's just a value, is it? And attacker clone, uh, then it will have its own shared, its own shared. So these two shared, because its type is primitive. For primitive, that dot clone method from object will make its own value, okay? Will make its own value. And so now the attacker clone already changes the shared to true. Is it from false to true? Because it's toggle it. And for attacker, it doesn't. So it's still false. Is it? So then attacker will try to do the update contents. Yeah, so can attacker do it? Yes, because it's false. So within the update contents, it said if the shared, if not shared, is it? And if not shared, if it's false and not false, so it is true. So then it will go into that loop, okay, to change, to negate it. Okay, so the array's contents, we can see a change. So then after that, we output, you will see, yeah, this clone, you will imagine it won't do that, is it? But we can see the attacker take advantage of this and changed it. The contents got changed. And the deep copy, yeah, it didn't get changed, okay? So they over here it just shows. Let's take a look at the running result. Okay. Yeah, we can see. Yeah, did you see the running results? The clone also get changed. You assume it's supposed not, yes, but it is. Okay. So here the problem, the here, so the problem shows is even though you see we make all of the methods in this superclass final, is it? Besides the constructor of the other methods are final, but you can see the attacker can still take advantage of that. Okay. And because of the implementation, if we are not careful, that so one recommendation for this is if we define the class itself as a final class, so like over here it shows, you define this class. So that means, please remember this class itself as a final class. Then we can avoid that issue. Okay. So then it will not allow someone to create a subclass, then using that subclass to attack, to do attacking for some database, like in this example shows. Okay. So that's the whole idea. Then it's recommended. So if you have strong security consideration, um, uh, for your project, then when you design your class regarding inheritance, then you need to be careful. Okay, okay. If some class has a highly security consideration, and you don't want it be don't want this kind of inheritance course security and the whole, okay? And then you can define the class as a final class. Then, because once you define as a final class, then, you cannot, so basically you avoid the issue with subclass. Then, just like in this example shows, then kind of, you see, here, you try to make use of, so here, create basically using that shallow copy, is it shallow copy? And because this part is the original database management, okay? But over here, it's because of this subclass. Subclass takes advantage of the not finalized, not a final class. Okay, so security whole, is it? So in order to avoid this, okay, take advantage. This is to take advantage using the shallow copy, is it? To take advantage. And so in order to avoid this, you can make that class final. Okay. If we make that class as final as previously I explained for a string, is it? So if you make this class as a final class, then when you suppose in this case, is it? So this is an instance of that final class. Okay. So it point to some memory location D. Okay. Yeah. So the contents inside So contents cannot be changed. Cannot be changed, okay. But this D, it can still reference to a new database member with new set of values. Okay, so that's still fine. Okay, so just be careful here. Okay, so this example mainly shows so sometimes even though you have a class that's not final, but you have uh, mem of the instance methods as final, then the attacker, so there's still going to be some security hole if not designed well, okay? So attacker can still take advantage to create subclass and then using that subclass to do attacking, just like our example shows here, okay? So if your project does have strong secure consideration, then in this case, just make the class as a final class. Okay. So basically, the class like the string class, okay, and those wrapper class, integer class, double class, okay, of those class, basically they are immutable, is it? And why they can achieve that is because they are final class defined. Okay. Okay, so that's the information in this chapter. So we complete this chapter. In our next lecture, we will start the new chapter. See you.